In this video, we will see how to use comparable and comparator for sorting list and other collections, and what is the difference between comparable comparator, and at the end we will also see what is a more efficient way of using the comparator interface. Okay, so first, what is comparable comparator? Why do we need it? Okay, so let's see an example of a simple class smartphone. It has three properties: brand, price, and storage space. One string, two integers. It can have any number of any types of properties. Okay, so it has some properties. What we want to do in the smartphone ranking is that we need to get a sorted list. For example, we have got a list of three smartphones with their price and their space. We want to sort it based on, let's say, price. And how do we do that? So instead of writing an entire for loop and comparing the values, which will be a very lengthy and inefficient way of doing it, what we can do is we can use collections.sort, which is already provided to us, and provide the list, and it will do the sorting for us, as simple as that. The problem being, it will not work because it does not know on which property to sort the list. Okay, we have got multiple properties. How is it going to know on which property and in which order it needs to sort it? So what we are going to do is we are going to use comparable interface, and that will tell this function how to sort it. Okay, so for that, we need to go to the original source code of the domain class, and we need to implement comparable. Comparable is an interface. We need to give the type, which is smartphone. Okay, so we need to implement whenever you implement an interface, you need to override the functions, and that is why we are getting this error. So what we'll do is we'll implement it. Now add unimplemented method. So once we do that, we get a compare to function. Okay, so what we are going to do is we're going to clean this. Okay, what we can see that we need to return an integer. And how does this work? So basically, uh, okay, I'll just tell you once I have written the code. Return integer dot compare. First will be price, second will be o dot price. Okay, now if you do not understand it, don't worry. So this is our code. Okay, if you don't understand it, let me explain it. First is we are getting one object of type smartphone, and we need to return an integer. Okay, so first, if you don't know what integer.compare does, so what it will do, let's say if we are comparing integer.compare a comma b, so what it will do is that if a greater than b, then it will return what? A positive number 1. If a is less than b, then it will return a negative number or -1. Okay, negative, any negative number will do the same thing for the compare to function, but compare function is going to return -1, and then integer dot compare, and then if a equal to b, then it will return 0. Okay, so that is basically what integer dot compare does. Now let me remove this. Once it returns a positive negative 0, based on that, this compare to function will sort it. So let's say this price is for the calling object, so this will be this dot price. Okay, we don't need to write that, but you can understand. And this price is for the object that is passed as the parameter. So using this compare to function, our collections dot sort will be able to compare. To sort something, you need to be able to compare the elements, right? If you want to sort an array, you need to compare the two elements of the array, any two element at a particular time, right? So how does it compare? So based on this, if it returns a positive number, if this returns a positive number, then it will put the calling function as the greater object. Okay, the calling object as the greater object. If it returns a negative number, then it will put the calling object as the lesser object. and if it returns 0, then it will consider both the calling object and the object that is passed as parameter to be equal, and it will sort them accordingly. Okay, so positive is greater, negative means it is smaller, and 0 means both are equal. So that is how it works. Now if we go back to our class, we can see that there is no longer any error. Let me just go compile it. So Java C smartphone ranking dot Java, then Java smartphone ranking, and we have original list, which is the way we created Samsung, OnePlus, Nokia. We have the sorted based on the price. We can see 14, 16, and 22. So it is based on the price. It has sorted the three items of the list, the three objects of the list, and presented us. Okay, so that is how comparable works. Now if you see, it is a very simple implementation. We just need to add an override a function, and we can use a sort. But there are certain limitations with this approach. What are those limitations? First is you cannot always modify the domain class. Sometimes you do not have access to the domain class. Sometimes you are restricted. Do not have the permission to modify the original domain class. Okay, and sometimes you just don't want to mess with the domain classes. Let them be how they are and work on the upper layers. So what we are going to do over here is we are going to restore it back to its original state. Remove this. Let me just comment it. Okay. So now this is the original smartphone class with only the constructor, the getter setter, the toString, the normal stuff, nothing special, a normal Java class. Now when we go back, we see that we are not able to use sort anymore. So let's comment it out. So now there that was a limitation of comparable. There is a second limitation of comparable. Here we saw we were only able to sort based on the price. For example, if we wanted to sort based on the space, we can't do that. If we had another one, say RAM, we can't do that. We can only sort it based on the value that is passed, that is being written over here. The value that we have mentioned inside this compare to, it will only compare based on that. Okay, we cannot have a dynamic like we cannot compare once based on price, then later based on space. It is limited with only one default property that you can use to compare the objects. So these two disadvantages we will handle with comparator interface. Comparator is again an interface, but we're not going to implement it over here because we can't modify the domain. Let's assume that we can't modify the domain class. So what we are going to do, we are going to create two new classes. You can create any number of classes. We have only two such properties worth comparing, so we are creating two. What we were doing, we were only comparing based on price. Now I want to compare both based on price and also storage space. So first for price, I create a comparator. Okay, and I'm passing, so this is get price, so it is just the same as compare to function that we saw over here. Here we have compare to belongs to comparable interface, whereas compare function belongs to the comparator. Okay, it belongs to comparator interface. So again, so we have created a comparator which is implementing comparator interface. This is a price comparator implementing the comparator, and it will have to override a compare function. Inside this we are passing two objects instead of passing one object in compare to. We need to pass both the objects that are to be compared, and then we are just comparing based on price. So this is just integer.compare, the same thing that we did in the previous one. And same, we have a similar, we have a space comparator class that is implementing comparator. Here the only difference is we are comparing based on the storage space of smartphones. Okay, so now we have comparators. How are we going to use that in our ranking class? So how we can do is we need to create objects of those comparators. Okay, so let's say smartphone price comparator of type smartphone. It will let's say price comp. Okay, price comp equal to new smartphone price comparator. Okay, I think we don't need to provide because it is not a generic, right? This is, yeah, we don't need generic over here. Similarly, we can create any number of comparator objects. This one will be for the space. So space comp equal to new smartphone space comparator. Okay. So if you have 10, 20, any number of properties, you can create any number of comparators. So once you have this, what you need to do, you need to, why is this giving an error? Oh, sorry. So this is space. Okay. So once we have the comparator, we just need to send it into collections.sort. So earlier we were just passing in the list. Now we need to pass two things. So we are already printing the original one. Let me just sort it by price, collections.sort. The list is smartphones, and the second one will be price comp. Okay, then system.out.println after sorting by price, system.out.println after sorting by space. Just add that collections.sort and then we need to compile it. So now we get the original, which is as we created. Then we get sorted by price, which you can see 14,000, 16, 22,000. Okay, then we have by space, which is 32, 64, 128. So we can use it to sort based on any properties, and we didn't even have to modify the original domain class. Now there is one problem with this, is that just for comparing we need to create an entire class, and it only consists one function with one line of code. This is not very efficient. So to make it efficient, what we are going to do is we are going to delete all the comparators. Okay, let me just compare. When we delete it, we can't use the new keyword anymore because we don't have. So we'll just remove these two. Okay, but when we remove it, we need to still pass objects, right? Objects of comparator. So we need to pass comparators inside the sort. Otherwise sort will not know how to compare the objects. So for that we will be creating comparators using a function called comparing. Okay, the earlier function was compare, which is used to compare the uh, objects based on properties, this function will be comparing comparator.comparing, which is used to return a comparator. Okay, so how does this work? We'll just do comparator of type smartphone. Okay, and it will be let's say price comp only. The same name is equal to comparator dot com. I'm not going to use that. Let me type it out. Okay, comparator dot comparing, and inside this what we need to do is method reference. So this will only work after Java 8. Okay, Java 8 and beyond this is going to work. Before that this method will not work. So what you need to do here, you need to type the class name, which is uh, smartphone, and then method reference get price, because it is based on price. Okay, so we have got a price comp object which uh, is comparing based on the get price function. Get price is just returning the price. Okay, and similarly we'll just create one over here for base comp equal to comparator dot comparing uh, remove. Okay. So class name, method reference, function name will be get storage space. Okay, let me save it, compile it, and then run it. So we can see that it is working just as before, but we did not have to create entire classes for it. Okay, just one line, one line of code to create the comparator object price com space com, and then just use the sort function as you are using and pass the comparator as the second parameter. Okay, simple. If you want to do it in reverse order, then it is just collections dot reverse order, and just pass the comparator inside that reverse order function. Okay, so just do this and it will be in reverse order, the comparator you are passing, and just surround it with collections dot reverse order. Okay, so that is all for this video for comparable comparators. Bye.